Hi, in this video, we're going to do a walkthrough of the chapter 16 example on propensity score matching. Now, this is a very common problem that exists in marketing because, for instance, as you'll see in our example, we might want to run a campaign, in this case, an email campaign, but we may not have everyone's email. So we send emails with our promotional campaign to those who we have, and we want to then measure the effectiveness of that email campaign and say something about perhaps its return on marketing investment. Now, the challenge is that the people, if we want to compare the email campaign group to the non-email campaign group as a way to see how much better sending an email did, the issue is that there might be what's called a selection bias problem, in that people who gave us their email addresses might be inherently different than those who chose not to. So what we're going to do is look at how much would we perhaps misallocate the benefit of the email to if we compared the groups without matching, to what if we were able to find a group of non-email providers who looked very similar to those who provided us with their email, and then compared the effectiveness of the campaign. So we'll go ahead and start in R, do the analysis and the matching and run the model, and then we'll go over to Tableau and see how we might visualize some of these results. So starting in R, the first thing we're going to do is we're going to open the R code. So this is called PS matching. And as we usually do, we'll go ahead and make it bigger so we can see it. And the first thing we always do is check to see if there are any packages that we need to install. Looks like there are 3. We're going to install a package called Match It, which is going to help with the matching. And then we're going to install Dippler, which will help us with visualizing, in the sense that we're going to look at some differences across groups. So it'll help us create what are called tibbles. And the last package, AER, is going to help us run the specific model we want to in this case, which will be a Tobit regression model, which we'll talk about a little more later. So let's go ahead and install these 3 packages. I'm just going to bring them from the cloud. Okay, so next step is we're going to go ahead and load the libraries of these 3 packages and set our random number generating seed. Okay, so next step, we're going to bring in the data. Now, the data we have is a customer database where we observe both the people who gave us their email addresses and received the campaign, and people who we don't have their email addresses for. So this file is going to be a file called retail_PS match. And as per usual, we can go over, click in the console window, and we can type head PS match. And this will show us some of the data. We see the first 6 customers. We see a dummy variable of whether we have their email or not. We see if they purchased in the campaign period, how much did they spend? What before campaign, so this is the 2 years before the campaign, what was their revenue, total revenue in that time, how many orders? If you remember back to our chapter where we talked about RFM models and logistic regression, we said in logistic regression, frequency and frequency squared are often useful. And then lastly, when was how many days since their last order? So this is the data we have for about 27,000 customers. So the first thing we're going to do is we're going to look at the data and sort of cut it by, create sort of a crosstab table, cut it by different factors. So in this case, we're going to look at the pre-match data and see about the differences in purchase amounts during this time period. So this will create a little table for us. It'll sort people by whether we have their email or not. So we have about 17,400 customers in our database where we don't have their email, and about 9,271 where we do. And during the campaign, we see the average purchase amounts of the no email customers, about $13.40, and for the email customers, about $24.90. Now, we could stop here if we believe that these two groups were randomly assigned, right, as a normal ideal experiment would want, but we're going to assume that, in fact, there might be differences between the groups. So what we're going to do is engage in some degree of matching. How do we know whether we might need to do that? Well, let's look at our X variables, our revenue and orders and recency and so on, frequency, and see whether or not these two groups are similar, right? So this next tibble that we're going to create is going to look at those. And what do we see here? Well, we see that on average, there's a lot of difference. Customers who gave us their email have spent a lot more in the past. They've ordered more times. The square of that order is also large, but they've ordered on average 7, almost 8 times in that time period versus 4.5 for the no email group. And they're more recent. On average, they've bought in the last half year, and this no email group is a little more than a half year. So there do seem to be underlying differences between these two groups that we might want to control for. So what we're going to do is actually try and find matches. We're going to try and find people in the email group who look like people in the no email group. And matching is done using logistic regression, which we've talked about in one of our other chapters, where it'll look at the probability of a given customer being assigned to the groups based on their past purchase data, right? This information. And it's going to look for people who look similar. Now, you could do what's called exact matching and find people who have exactly the same profile. The problem with exact matching is that usually you lose a lot of your sample that way. So what we're going to do is not do exact matching, but we're going to do matching where we allow for small amount of variation in the predicted probabilities. How do we figure out the optimal probability to allow for difference? We determine our optimal caliper size by essentially running a model and looking at what amounts to be a small standard deviation difference from our propensity score. So we'll go ahead and run this part, and this will tell us what our optimal caliper size is for matching. So we see here our optimal caliper size is about 2.3, 2.4%. So we're going to say as long as your predicted probability is less than that, you can be considered a match with someone in the other group. So now we're going to execute our matching algorithm. That's here. We're going to put in our caliper we just got from here. And then we will go ahead and look at the results. So if you remember, we have about 27,000 people in our total data set. Let's go ahead and run this and see how many we can match. So this is going to run that logistic regression to see what might explain people's group membership, and then score them by predicting the probability of their membership in each group, and then match them where the matches have to be within the limit of the caliper. So this ran, and we see that we're down to about 17,900 rows from our total of about 27,000 rows. Now, we try to match a person in the email group with someone in the no email group. So ideally, if we matched everyone, we would have 2 times 9,271, right? Which is, I guess, about 19,400 or so. We see here that we did lose some of those people because we couldn't find matches for them. But if we divide this number by 2, which is just a little bit less than 9,000, we lost about 700, a little over 700 of our email customers who just couldn't find matches in our no email database. Okay. So now that we've done the matching, we can check and see how good our X variables were at matching. So these were the differences before matching, right? So now let's go ahead and look at the post-matching differences of those variables. So what do we see now? Well, we actually see that revenue is coming closer. We lost some of our high revenue customers from before because we couldn't find matches, but we picked up all of our higher revenue non-matching customers. Pretty equal in terms of number of orders, pretty equal in terms of recency. So now we have two samples, a no email and an email sample, that are a little more similar in their past behavior. And we can maybe make a stronger argument that the result of the analysis with this group, where we have a matched sample, is going to be a little more representative of the true value of the email campaign. So the next step we're going to do is we're going to run the model. Now, we could run a linear regression, but the issue we have is that we observe during the campaign time period that people either purchased, in which case we see some positive number for the revenue, or didn't purchase, in which case we see a 0. So we have what amounts to be data that's censored at 0. Either if a purchase occurred, it's positive. If it didn't, it's 0. So when that happens and we have this censoring, the type of regression model we try to run is called Tobit model. A Tobit model is one which first predicts the probability that someone buys, and then conditional on buying, how much do they spend, right? So it's going to be the combination of those two in predicting the result. So we'll go ahead and run the Tobit model here with those variables, right? The treatment variable and all of our matching variables. We see here that the variables are significant, so they are good explainers of the value you spend during the campaign. We specifically see our treatment effect here, email, is positive and significant. So we expect now to see that email does have an effect. How much of an effect? What we need to do then is take this result, these coefficients, and predict what we expect someone to spend and compare it to the prediction of the group that did not get the email. So in this section, we're going to create the predicted value, and we'll call it predicted purchase amount. You can see here, and that's just going to be the probability that somebody buys, the predicted probability, times if they buy, how much do they spend, right? This will give us our expected value. So we'll go ahead and run this. So now we have the predicted purchase amount based on the match sample and the regression that we ran. Let's go ahead and compare those predicted values. So that's going to create that tibble, which will actually compare the two. And what do we see here? Well, we see now that in fact, based on the model results and the matching, that the difference between the two groups is about $3.60. So it suggests to us that after matching, our email was able to incrementally generate about $3.60 of additional revenue relative to no email. Now we can also go back and run the same analysis on the unmatched data and see what happens, right? So this whole section here is the same analysis, but we're going to keep the pre-matched groups and see what happens. So the model runs and so on. And again, we get down at the bottom here, and this is our pre-match data. If we did not do the matching, we would say that the email would potentially have about $12.70 worth of value. But what we see here is that these are very different groups of people. And so when we do the matching, if we scroll back up, we see that in fact the email is closer to about $3.60 worth of value because it also didn't take into account, when we didn't match, the differences among the two groups of people. So now that we've done this, we have these variables. Let's go ahead and output this, and we can bring it up in Tableau and see how to maybe visualize a table of the results. So this last row, we're going to go ahead and write out a CSV file. We're going to call it psmatch_predicted. Okay. So now let's go over to Tableau and visualize these results. So the first thing we're going to do over here in Tableau is we'll go ahead and we will open the data. So we're going to open and we're going to bring in the PS match predicted data that we just created. All right, and here's the data, and we can see all the way over here on the end, we have the predicted purchase amount that we had before. So let's go over to sheet one. Now, what we need to do here is we do have the predicted amounts. We can also look at other types of variables. So we're going to create two calculated fields. We're going to measure revenue differences before and after. So we already have predicted purchase amount and purchase amount. Let's go ahead and do revenue change and predicted revenue change. So we can go to analysis, create calculated field. We'll create one called revenue change. Now, remember, the revenue variable that we have in our data is for the past 24 months, the 2 years. And our campaign was a 1-month campaign. So if we want to make apples to apples comparison, we want to compare the purchase amount to, in this case, the revenue divided by 24 to give us the per month average revenue. For predicted, we can again create a new calculated field. This one we're going to call pred revenue change. And in this case, we'll do something similar. Instead of just purchase amount, we'll call pred purchase amount minus, and in this case, revenue divided by 24. So now we have these different variables that we can put into a table. The first thing we want to do is tell Tableau that our customers and our emails are both dimensions, not measures, because we want to be able to group people in that way. The next thing we're going to do is we can go ahead and move email over to columns. You'll see that it now is going to sort by the two groups. Let's go ahead and move over predicted purchase amount, predicted revenue change, purchase amount, and revenue change. So we'll go ahead and double click that. It's going to show up here. Let's see, we also want predicted revenue change, and we want purchase amount and revenue change. So these are all sums. We're going to go ahead and click and then hold shift and highlight the whole group and change it to averages for the groups. We also notice that these are dollars. So we're going to go ahead and click format and change them to currency. Right. We'll make this a little bit bigger so we can come up to format up here and choose font, and we'll pick, let's go ahead and make it say 16. Let's move this over so we can see a little better. We'll go ahead and name this guy. This is going to be comparison of predicted and revenue gains. So what do we see from the results? Well, we can see here that on average, so if we look at the predicted purchase amounts, we can see that's the difference of the two groups. So that's the approximately $3.60 we saw in that Tibble and R. Compared to the actual purchase amount, so this is the model based and this is the actual, pretty similar results, right? So you see here it's just a little bit under $3.60, but our model was able to pretty accurately get the difference. If we look at the revenue change as well, right, we see here that on average, the revenue from before to after, and this is the actual. So this would be based on the model result, and this would be based on the actual. And so what we can see here is that our model did a pretty good job of capturing what really happened. But what we noticed when we ran the pre-matched with all the data that there were a lot of differences between people who gave us their email and who didn't. And so we had to be careful about just directly comparing those two groups, since they were made up of very different types of customers. So we engaged in matching. We tried to find for each email customer a non-email customer that looked similar in their past behaviors. And by doing that, we hopefully get a more accurate assessment of the effectiveness of our email campaign. And then we can go back and measure things like return on marketing investment, where we now know that our email campaign generated about $3.60 worth of an incremental revenue per customer. We could figure out the cost of running that campaign, divide by then the cost, so we can do incremental gain minus email divided by email cost, and figure out our return on marketing investment. So let's go ahead and save this. So we'll say save as, and we're going to call this PS match. And we will save it as a Tableau packaged workbook so that our data is included here as well. And now we have done the analysis to match and measure the effectiveness of our email campaign using the propensity score matching.